Thank you to AnyDesk for supporting PBS. This is a problem that can break the entire idea of infinity. It starts with a vase and infinitely many numbered balls. Let's start 1 minute before noon. I put balls 1 through 10 into the vase. Then I remove ball number 1. 30 seconds before noon, balls 11 through 20 go in, and I take ball 2 out. 15 seconds later, half the way to noon, 21 through 30 go in, ball number 3 out. We keep going, each step half as long as the last, forever. At exactly noon, after infinitely many steps of adding 10 balls and removing 1, how many balls are in the vase? The answer is infinite, and also 0. Both are correct at the same time. This is a video about how infinity doesn't mean what we think it does, and what happens when our brains try to make sense of more than everything. Hey smart people, Joe here. How long does it take for infinity to happen? That question sounds kind of ridiculous. Like if you ask ChatGPT to do a Vsauce impression. Can never do that. But to prove it, just imagine walking across a room. First, you have to cross half the room, then half of what's left, then half of that. Infinite steps, each step half as close to the finish, but never there. Yet, here I am, across the room. This very problem was devised by the Greek philosopher Zeno 2,500 years ago. He wanted to prove that motion is impossible, which we know is silly, because it is obviously possible. Look! Zeno was right that there are infinitely many steps, but he was wrong that they add up to infinite time. You see, if each step keeps getting shorter fast enough, infinite things can fit in finite time. Half a minute, plus a quarter minute, plus an eighth of a minute, so on forever. That adds up to exactly 1 minute. Infinite steps, finite time. And completing infinitely many operations inside of a finite window, that's what mathematicians call a supertask. You can't do a supertask with your real human hands, but the mathematics works. And that math forces us to ask some pretty weird questions about how infinity is different from, non-infinity. When you take supertasks seriously, infinity starts revealing some deeply strange stuff. Let's say that you run a hotel with infinite rooms, and every single room was occupied. A new guest shows up at the front desk. Instead of telling them no vacancy, just ask the guest in room 1 to move to room 2 to room 3, and so on, forever. Now, room 1 is free. The hotel is still completely full, but you've still added a guest. The rooms represent an infinite set. You can add to the whole without changing the size of the whole, and both are still infinite. This sounds ridiculous, but this isn't a glitch in the math. So what happens if 10 guests arrive? You don't need to break a sweat. You just get on the intercom and ask every current guest to move to the room 10 numbers higher than theirs. Room 1 to 11, room 2 to room 12, and so on, forever down the hall of infinite rooms. But now rooms 1 through 10 are empty, and all 10 new guests get a bed. And the hotel is still completely full, just as it was before. So what if an infinite bus arrives, carrying infinite guests? Trickier, but you have a move for this too. Just ask every current guest to move to the room that's double their current number. Room 1 goes to room 2, room 2 goes to room 4, room 3 to room 6, and so on. Now every odd-numbered room in the entire infinite hotel is empty. And since there are infinitely many odd numbers, every passenger on the infinite bus gets a room. We've fit infinity inside of infinity. Now, let's say inside every one of those infinite rooms is a lamp. 1 minute before noon, you flip the switch to on. 30 seconds before noon, lamp off. 15 seconds before noon, on again. The flipping doubles in pace forever. We flip the switch infinite times before noon arrives. So, at exactly noon, is the lamp on or off? There is no right answer. Not because we haven't figured it out yet. There literally isn't an answer. When we get to noon, it doesn't end on, it doesn't end off. It just ends. This is one of the things that makes supertasks so weird. They can end without a final ending state. Problems like these introduce ideas that are hard to accept because they don't match our experience in the real world, but they are still just as true according to mathematics. Infinity isn't one thing, and some infinities are bigger than others. The whole numbers go on forever. 1, 2, 3, 4, etc. And the fractions go on forever too. But we can pair every fraction to a whole number, 1 to 1, with nothing left over in either set. So these infinities are the same size, but the decimals don't work that way. There are too many of them to match these infinities. In the 1870s, mathematician Georg Cantor proved this, and his argument is an elegant one. Suppose that you claim to have a complete list of every decimal. This one, and so on. We can attempt to match every decimal number 1 for 1 with every whole number, but I can always find a decimal that's not on your list. Take the first digit of your first number and change it. Take the second digit of your second number and change it. The third digit of the third, and so on. The decimal I've built differs from every number on your list in at least one digit position. So your complete list of decimals isn't so complete after all. Cantor showed that whatever infinity you're looking at, you can always construct a larger one. The decimal infinity is bigger than the whole number infinity, but there's an infinity bigger than that one too, and one bigger than that. The ladder of infinities goes up forever. Infinity also breaks arithmetic in a way that honestly kind of bothers me. Take this infinite series. 1 minus 1 plus 1 minus 1 plus 1, and so on. What does that equal? Well, group the terms one way and you get 0. But start from a different grouping and you get 1. We can even rearrange the math in a different way. Let's subtract this series from 1. Do some basic algebra to rearrange things, and the answer ends up being 1/2. It's an equally valid answer, but for certain infinite sums, the order that we add things up changes the result. Which brings us back to the vase. This thought experiment was originally devised by mathematicians John Littlewood and Sheldon Ross. It's known as the Ross-Littlewood paradox. And it's a paradox because two completely true lines of reasoning can give us completely opposite answers. Recall that at every step we add 10 balls and remove 1. And each step is done in half as much time as the one before. A net gain each step of 9 balls. So after 10 steps, roughly 90 balls. After 100 steps, 900. Run that out over infinitely many steps, and the number of balls in the vase is infinity. Then again, maybe the vase is empty. At noon, which balls are in the vase? Let's pick any ball. Ball 47. That went in during step 5, and it came out again during step 47. Ball 1 left in step 1. Ball 1000 left in step 1000. Name any ball and I can name the exact step when it was removed. So at noon, after infinite steps, there is no ball in the vase that wasn't eventually taken out. But suppose instead of removing the lowest numbered ball, I change which ball I take out each step. Same deal, 10 balls in, 1 ball out. But now, instead of removing ball 1 in step 1, I remove ball 10. The last one that I just added. Step 2, balls 11 through 20 go in, ball 11 out. Step 3, balls 21 through 30 are in, ball 12 out. And so on. Now which balls are left at noon? Ball 10 was removed in step 1. Ball 11 in step 2. Every subsequent ball gets pulled out in some future step, except balls 1 through 9. Nobody ever touches them. No step exists where they get removed. Exactly 9 balls remain at noon. We did the same process at the same rate, 10 in, 1 out, every single step. But by changing which balls I remove, the answer went from infinity to 0 to 9. The vase doesn't have a true answer because the answer is whatever the process says it is. All of these arguments have sound logic. The secret is that each scenario in our paradox is actually tracking different things. One watches the size of the set at each step and then extrapolates forward. The second traces the fate of individual balls. And the third shifts how we group things to get a totally different answer. In truth, we can't have an answer for what happens after infinite steps because there is no final step at all. Asking what's in the vase at noon is like asking What's north of the North Pole? The question makes grammatical sense, but doesn't refer to anything real. The vase and balls paradox doesn't really have a solution because the fact that it has many solutions is the solution. This is what infinity actually is. Not a very large number, not the number at the end of the number line. I've learned to think of it as a direction, a process, something that you can approach forever without ever arriving. Treat infinity like a number, and it will fool you. Mathematics can describe what happens at every individual step. It's a beautiful machine that can take our brains right to the edge and then show us that the edge isn't there. Stay curious. And thank you to AnyDesk for supporting PBS. AnyDesk was created to provide fast, secure remote access, whether you're working from home, on the road, or managing systems across multiple locations. With AnyDesk, you can remotely access computers and servers directly, enabling secure file transfer without relying on consumer cloud storage. And there's no unnecessary data collection. It's lightweight and privacy respecting. Plus, AnyDesk is built with their proprietary codec DeskRT and runs on servers that use Erlang technology. This helps ensure minimal latency and crisp visuals, even over slow or unstable internet connections. AnyDesk is available for personal use, but if your research requires a lot of global coordination, AnyDesk offers custom-tailored business plans too. To learn more about AnyDesk, go to anydesk.com/besmart or check out the link in the description. And as always, thank you to everyone who supports the show on Patreon, including these fine folks at our top tier and everyone else who's part of our community. You help make this show possible in a very real way. Videos like this take a lot of resources and time and energy to put together, and we could not do it without you. I am infinitely grateful. See you in the next video. More than everything. Rest of the episode. Paint it out. It will fool you. Don't kick the stool in the middle of your line.